Okay, this is a video about surface area of right prisms. First of all, what is a prism? A prism is basically a three-dimensional shape, and it's where if we cut along what's called the main axis, we would get the same cross-sectional shape. So if you think about, I don't know if you've ever seen someone feeding a big dog, and you might have a tin of dog food, and we have something like this and that. We know this as a special sort of prism called a cylinder. Okay, and what happens, we feed this dog, and out comes the dog food, and of course it's the same shape as the can, isn't it? Have you ever seen this? Wet dog food, big dog, and the dog food. And of course if you got a knife and you cut along there, if you look down the end, what shape would it be? Circle. Each slice would be a circle. Another way of looking at it, if we look down here at this one on the left, this is a triangular prism. If we cut along here, we would get a triangular face the same here and the same there. We cut further down, be the same again. Alright, so we're getting that same triangular cross-sectional shape. There's also rectangular prisms and so on. This one here is a non-example. This is not a prism. It's three-dimensional, but it's a pyramid. It's not a prism. Cones and pyramids are not prisms. And when you cut this one, sure, you get this cross-sectional shape the same, but it gets smaller as we go up. And so you'll get that square or rectangular base, but it will get smaller as you go up and cut further up. So the changing size of the base means it's not a prism. So, solids are not necessarily prisms. It's only if they have a constant cross-section. What's a right prism? Well, it just means that the height and the base are at right angles. So something like that one is. But if it was offset a little bit, like over here, okay, we still have flat top and bottom, but you can see that these sides here are not at right angles, whereas here you can see the right angle there. Okay, so that means it's right angled or a right prism. We're going to be focusing on right prisms only. Surface area is something that you've probably heard about before. It's something that sometimes is made out to be more complicated than it is. It's actually quite a simple idea. It's actually an application of area, which we've been looking at. Alright, so it's an application of area, but it's basically adding all of the areas of all the outwards facing surfaces of a solid together. Okay, like in that rectangular prism I've just put arrows on. So it would have 6 faces, and because it's a rectangular prism, each opposite face is the same. So we know that each face will be a rectangle, and so all we do is add the rectangles together, all of the areas, and so we have what's called total surface area. With a rectangular prism, it's a bit like unfolding a carton. If you unfolded a carton, let's say it was a soft drink carton and had cans of soft drink in it, I know there's little tabs and extra bits on a real box, but ignoring those, if you unfolded a box like this, a rectangular prism, you'd have this diagram here, which you might recall is a net, N-E-T. And that net basically shows you, it's a handy diagram which shows you all of the rectangles we need to add the areas of, which are all length by breadth, and there's pairs of them. So if we see here, the working for it, total surface area of the shape is 2 lots of 5 times 3, and that's the top and the bottom. It's 2 lots of 5 times 2 added on to that, and added on to that is 2 lots of 2 by 3. So the 2 by 3s are there, the 2 by 5s are here in green, and in black are the 2 lots of 5 by 3 there. Okay, and we have 2 lots of 5 by 2 there, and we have in the blue 2 lots of 2 by 3. We add that together. Notice how the units are squared units. Total surface area. The main one I find that students need to be careful of at this stage in the course would probably be the triangular prism. So a triangular prism like this one here, we need to take a little bit of care with that, because it's got 2 heights. It's got a height here, and then for the triangle it's got a perpendicular height like any triangle. Okay, so we have to be careful with that. But again, it's if you drew the net of it, you just have to be careful. This would have 2 triangles, a rectangular base. So you've got the rectangular base, and on the rectangular base you've got your 2 identical triangles. Then you've got 2 sides that come off, which are 2 more rectangles. That's a bit crooked, isn't it, Mr. Herbert? And then sometimes they are, these 2 rectangles are usually the same, but sometimes they're the same as this one as well too. But it's a rectangle plus a rectangle plus a rectangle. These 2 may be the same, sometimes they're the same as this one. And then remember the area of a triangle, which is base times perpendicular height times a half, and we add it all together.